This is part 4 of AVR GCC programming. We continue with other operators. The next group of operators are bitwise logic operators. For example, bitwise in, as you can see, this is a single ampersand sign. Compared to the logic operator, logic in, which is double ampersand sign. Bitwise in means we in the values bit by bit. For example, we got a variable a holding a binary value of this, and then another variable b holding another values of this, and then we use bitwise in to in these two variables, and then resolve back to x. Let's look how the CPU will do that bitwise in. So here is the value of I, value of b, and then the CPU will bit those values bit by bit. For example, the LSB 0 in 0 equal to 0. The next bit also 0 in 0, and then next one 1 in 1, which is 1. 1 in 0 equal to 0. 1 in 1 equal to 1. And then 0 in 1 equal to 0. 1 in 1 again equal to 1. And then 0 in 0 equal to 0. So that's the result for x. Bitwise or a single pipe. Look at another example. We got I, the same value as the previous example, B, the same, and then we use bitwise OR operator to bitwise all those two values and then assign the value back to x. How the computer will execute it? Look at again. It will all the value bit by bit. First for LSB first, for example. So 0 equal to 0. That's the same. And then 1 equal to 1. 1 also equal to 1. 1 equal to 1. 0 equal to 1. And then 1 equal to 1. 0 equal to 0. So that's the value x will get after this operation. The next bitwise operator is ones complement. The symbol we use is a tilde. So the ones complement operation is only the operation on a variable. For example, I holding the value, and then we ones complement the value of I, and the value will be assigned to x. So here's this computer how to do the operation. So got the value. It will change each value into opposite 0 to 1, 0 to 1, 1 to 0, and then 0 to 1, 1 to 0, and 0 to 1. So that is the ones complement. The value will be assigned back to the variable x. The next bitwise logic operator is exclusive OR. Bitwise exclusive OR. So we got two values holding by I, and then another value holding by B. And we use the exclusive OR, bitwise exclusive OR, to do the operation on these two values, and the result will be assigned back to X. Now, how the computer will do that? Exclusive OR bit by bit. So the first bit 0 exclusive or 0 equals 0 because both input are the same, so outcome is 0. Same for next bit. The same for next bit, both input are 1, they're the same, so outcome is 0. And the next bit are different, so the result will be 1. The same, 0. Different again, 1. The same, 0. And last one also the same. So that is the result of bitwise exclusive OR. The next group of operators is shift operators. We have two of them. One for you to shift to the right-hand side, the other one is for you to shift to the left. Every time the value shifts to the right by 1 bit, the value will be halved. The value shift to the left by 1 bit, the value will be doubled. Shifting to the left is very useful in microcontroller programming. For example, we got x equal to 1 shift to the left by 3 times. 1 here is the value, change into binary will be 70 and 1 in the LSB. 3 is the number of times to do the shifting. If we shift once, for example, the 1 will shift up from LSB up to 1 bit position, and the 0 will be shifted in. Shift it again, and shift it again. Now, after 3 shiftings, the value 1, as you can see, in the bit position of bit 3. So that expression, 1 shifted 3 times, actually we set the 1 in bit 3 in the binary number. In C, you can use if statement to make decision based on the condition given here. If the condition true, this block of instruction will be executed. If not true, this block will be skipped off. And the condition can be a comparison, can be logic expression, can also be a single variable. In C, the value of 0 will be used to represent false, and non-zero will be true. You can also use if-else statement to do decision making. Here's the condition. When the condition true, the first block of the statement will be executed. Otherwise, the second one will be executed. Either one will be executed. True for this one, false for this one. In programming, if you want to do something again and again, you can use looping. If you want to loop a given number of times, say 10 times, in C language, you can use for loop. In for loop, you need to have a counter, and normally starting from 0 and stop just before 10, and then increment it each time. So starting from 0, keep looping up to before 10, so that you got 10 times. So here's the loop body, will be executed 10 times for this example. If you want to loop when some condition true, you can use while loop. For example, this is the condition for the while loop to continue. X greater than 100, and then we'll keep looping if this condition true. Using while loop, you can make it as a endless loop if you put the condition is 1. As I mentioned before, 1 means true in C. So this condition is always true, and this block will be executed forever. After this video clip, we are going to write a demo program to simulate a night rider in port I in the microcontroller we have. Here's the flowchart we have used to develop an assembly language to simulate the night rider in port I. As you can see, there's 2 inner loop and also have an outer loop back from here. And based on this flowchart, we have written our assembly language. And there's a main routine. And also we have to write a delay subroutine, which is a quite lengthy program. We are going to use a similar flowchart and write a C program for it. And later you compare what's the difference between C language program and assembly language program. See you next time.